And thank you, everyone, for being here today. It's with great pleasure that I'm going to present you the research I've been doing in the last 3 years. I'll try to make this presentation a little bit different than usual in the sense that first I introduce the main topics of enterprise architecture and digital manufacturing. And then I'll try to use my Ph.D. journey to present my research contributions. So let's start with who made this research possible. So my supervisor, Charles Müller, with his support and his supervision and industrial contacts, has played a fundamental part in this research. Then we also have Qualiware, a leading enterprise architecture platform, which has been funding this research and has been providing really a head start in this research because they provided the tool, they provided expertise, they provided developers to develop solutions. And so many thanks to Kuno Brodersen for his support and for his insights, and to John Götze, who is head of the Center of Excellence and the co-supervisor for all his work and managing also the relationship with Qualiware, introducing me to the enterprise architecture community, and last but not least, find a professor with whom I could collaborate for my stay abroad, because that was a very important collaboration with Shegnan Han from Stockholm University. We wrote together 2 of the 3 journal articles with also the other supervisors, but she put so much energy and time into the research I'm going to present here today, so it's also thanks to her. And then there is MADE. MADE is this network of manufacturing companies in Denmark. Most of you know about this, but I've been having several interviews with these companies and visiting them to really understand this digital transformation that we're going to see very soon. And they've been very important. And last but not least, the assessment committee for having evaluated, and I'm sure for driving an interesting discussion later. So let's get started with manufacturing. Why are we even talking about manufacturing? Well, it is very important in our society. If we think that 1 worker out of 7 in the world is employed in this industry, if we think that manufacturing deeply shapes our lives, the car most of you used today to come here, bicycles for some of you, or clothing or smartphones, it is a very important industry in our society. So let's get more into it. So manufacturing is the process of converting raw materials, components, and parts into a finished good that meets customers' expectations and or specifications. So you see here we have these parts of a car that then are assembled to produce the car that most of us drive today. And how does, in simple term, work a manufacturing company? Well, they have some different departments, and for example, the sales department tries to understand what are the needs of the client, of the customers, and documents this. And then there are some these documentation is used in the product development to design new products that meet these expectations. And this involves specifying the parts, specifying the processes, and all of this is then given to manufacturing, which is responsible for actually producing the products that are then shipped to the customers. And what is digital manufacturing then? Well, digital manufacturing is the application of data and information for the enhancement of manufacturing products, processes, supply chains, and services. So it's really the use of data that was not available before oftentimes because of smart products, for example, products that are able to communicate to the manufacturer how the product is used, when it is used, which failure or which issues it is experiencing. If we take the example of a car, like a normal car, well, when the driver feels that there is something wrong, might bring it to a repair. But then with a smart product, we can actually, or a Tesla car, if vibrations are recorded, or even the normal day-to-day use of the car is shared with the manufacturer, so that in the case of problems, first of all, the manufacturer is notified on time, and then the manufacturer also stores all sorts of data about that specific car. How was it produced? How it is being used? On which road has it been driven? To try to understand what might have caused the problem. And then what is interesting is that it triggers this kind of improvement process that involves like different departments and a lot of more communication and integration between departments, because suddenly how the car is used, some of this data might be used for the manufacturing to making sure that the parts are fit well, or maybe that the process needs to be changed. Because this is what we're talking about, like the fact that the product provides insights to make it better, to make better the product, to have better processes, and so forth. So it is this continuous improvement, we could say, that we are experiencing with digital manufacturing and smart products. So we talked a lot about data, and to manage all this data, what is very important, what many researchers but also practitioners refer to is this digital models that can actually structure the way we collect data, and they facilitate the way this data is then used, and they also facilitate these digital models, the integration between the different departments in a manufacturing company. And to do these digital models, when I started the research, some standards emerged to kind of guide this. Very little application of this. They were still under development, and actually, thanks to Qualiware, we had early access to one of them. And so, also when I started in 2016, there was way less knowledge than we have today. I think the amount of research that has been done on this topic in the last years has been actually significant. So if on one side we have identified that these digital models are very useful for improve the way an enterprise works, to improve the products. On the other hand, when talking with manufacturing companies, we discovered that they have a lot of challenges in actually using these digital models. And a lot of the challenges are related to the fact that information sometimes is hard to access, is stored on multiple systems, and you need to find the right people that can access this information, or you might simply don't have a good understanding of what are the processes, for example, in your department or in other departments that you have to collaborate or share information. And then there is the fact that this lack of standardization of information, that oftentimes companies refer to a customer in different ways, depending on the department, depending on the system that is used. And then, of course, they have a lot of data about the customer, but they're not able to use it and to merge this data to get some insight, because they can sometimes hardly identify which customer on one system is on the other. And then working with these companies, we also figured out that in some cases there are, especially large companies, international companies, have this problem that maybe they even have very similar processes for producing the same component, but because of historic reasons or environment reasons, they are different, these processes. They are very different. Maybe they are documented in very different ways, And they might even collect a lot of data about these processes to do process improvement, to do all of this. But then they cannot really use this data to compare the processes, to use this data outside the process. So this is the data and process and data heterogeneity challenge. Yeah. So this was digital manufacturing, and now let's look into enterprise architecture. Enterprise architecture is a discipline to manage enterprise-wide transformations. So transformations that involve different departments that are really involve the entire enterprise. And the aim of enterprise architecture is to effectively implement the overall enterprise strategy. And it does so by designing the different facets of the enterprise, the different aspects of an enterprise, to maximize coherency, to make sure that actually the entire enterprise is moving in the same direction. And it does so by using extensively these enterprise architecture models. And these models, they define the elements and relationships in an enterprise. This might sound a little bit vague. I have some examples now. But before looking at the examples, let me just say that usually these enterprise architecture models, they cover different aspects. Some of them focus on the business aspect, others on the application, and the technology aspects. There are different ways of representing this, but this is kind of the standard way. And let's get started. Let's see a few examples of enterprise architecture models. Here we have something that is used, for example, by top management to define what are the goals in our enterprise, what do we want to achieve. And it is also used to structure how the enterprise works, like which departments do we have, what should they do. And then we have these process models that define like the main processes in the enterprise, and they're used both by top management and middle management to really define how the enterprise works, what are the departments doing and how they're doing it. And they specify this at different levels of detail, so you can get in more and more detail how the departments are working using these models. As you can see here, there's the manufacturing process that then is broken into these sub-processes of prepare the parts, assemble them, and check the quality. Then we move into the enterprise architecture models that are concerning the application aspect. So what systems do we have? What enterprise information system do we have? Because like in large enterprises, but there are plenty of systems. They even have several systems for doing exactly for the same purpose. And so it is important to understand how is our application landscape. And then what information they share, for example. And then what is also important is to define which information do we have in our system. If you think about, for example, at GDPR that all of us have been bombarded with lately, you might identify that there is a customer information which is very sensitive information, and then by having these models you can see, okay, in which processes is this information used? And then you look at the process and then you say, okay, who is executing these processes in our enterprise? And then you can find who actually needs maybe an intensive training on GDPR because it deals with sensitive information whole day long. And then there is this more technology model that, for example, here they represent the databases, the infrastructure, which servers do we use, where is the data stored? Again, GDPR, European citizens' data needs to be stored in Europe. So you need to manage this somehow. And you can do this with enterprise architecture models. But these models are usually used by IT or specialists that need to kind of define these very technology aspects. Yeah. So, as we said, these models, they're used to define the enterprise on the various aspects of the enterprise. And in an example of digital manufacturing, you can you specify how is your enterprise today. So you use these models to do that. And then you define how you want to be in the future. Do we want to gather data from our cars so that we can improve the performance or add additional services? And then you define how the enterprise should be in the future. And you insert the new elements or the elements that needs to be changed. And then you develop this transition plan that guides the transition from the enterprise today to what it wants to be in the future. So enterprise architecture can really play a very important role in this digital manufacturing. But it is also facing important challenges. One of the challenges is that oftentimes is used to manage essentially IT, to manage the enterprise IT system, so the servers and these aspects, but it doesn't really go into looking at, in a manufacturing company, like the manufacturing processes, the product development or sales. This is one limitation. And the other limitation is that the models you've seen today, usually they are created manually, which is very inefficient, time-consuming, and also error-prone. So these are two important challenges. And so putting together these the challenges related to digital models and digital manufacturing and the challenges in enterprise architecture, this is actually my starting point for my research. And as I said before, I'll try to use this my 3-year journey to guide the presentation of the results. So in the first year, I try to focus on how can we actually use enterprise architecture models for digital manufacturing. How can we do this? And also investigate what are the problems in manufacturing companies, and through our connections and through MADE, really understand what are the challenges that manufacturing companies are facing. And then in the second and third year, I've been more focusing on this method to start creating these models semi-automatically, to start changing and start also using the data in our enterprise information systems to create these models. So, my research context, what was my starting point, and who were my stakeholders essentially in my research? Well, there was Qualiware, which has been really important, and they wanted to essentially experiment how can their platform, how can their tool be used for digital manufacturing? What is it missing? What is very valuable? And they wanted to get a better understanding of manufacturing and the digital manufacturing challenges. Then we have MADE, these companies, and when we were approaching them, they were seeking some kind of solutions or ideas on how they could manage this digital manufacturing transformation. And they face several challenges, so they were like looking sometimes for inspiration, and but they wanted to do so only if they could see already some preliminary results of the idea we wanted to present. So sometimes it was very difficult to interact with them without having a demonstrator to explain what we were talking about. And then there was Aalborg University, which has a learning factory. It has a production line, which is here in the next building, and we use this to create these demonstrators to then go to the industry. And yeah, produce high quality research, publish. This was maybe one of the main requirements from our university. So given this context, we could essentially distinguish between research that has the purpose to explain, describe, and predict phenomenon, and then research that has more the purpose of designing and evaluating artifacts, programs, methods. And then we can distinguish between whether the researcher perspective is an external observer, so it is not part of the manufacturing company that is in the case study, or it can be part of this case company. So in our case, I was with Qualiware, and it was very hard for also myself to be part of a manufacturing company, to establish this collaboration and get this role. So I would say it was mostly external observer. That was what I could do. And then, given the needs, what the interest of my partners, they also kind of driven or influenced the design choices in my research, because we wanted to see investigate some solutions to industrial problems, to research problems. And so we tried to do this by designing artifacts, testing them. And one thing that is very important to understand here is that even though we have identified some problems early on, when you start doing this type of research, the problem you have understood is usually not very clear. So then you start developing some solutions to what you thought was the problem, and then you test these solutions with some companies, and you get some feedback, and then you discover, oh, wait a second, the problem is a little bit different. So every time you get a better understanding of what is the problem, the more you work on it, the more feedback you get. This is very important to understand when doing this type of research. Yeah. So in the first year, as I said, we've been using these, developing these enterprise architecture models with Qualiware, and we did it in the learning factory. And we did so kind of to address this fact that sometimes some companies have the difficulty of accessing information because it's stored on systems, and also this lack of understanding of the processes and resources. And at the same time, we wanted to address the challenge that enterprise architecture is too much focused on IT aspects, and therefore we investigated which enterprise architecture models can be used as digital models for digital manufacturing. Our starting point was the laboratory, as I said before, which has this production line, and actually it has very important, it has the same IT systems that are used by manufacturing companies. So we have SAP, and difference, of course, is the data in it, but the system that the laboratory use, some of it is actually the same as in the industry context. But we wanted to start off with a more simple environment, more controlled environment where to experiment with this idea. And so we decided to apply enterprise architecture models using RAMI, which is one of the two standards that we mentioned before. And we tried to apply this, and what it came out is that some aspects of these digital models can be modeled with enterprise architecture models, and some are not. So this was kind of the important testing a little bit, what can it be done and what it cannot be done. also because we couldn't find a lot of literature out there about this. And I think, if I'm not wrong, that the standard was not published at the time we did this. So yeah, we also tried to reach some car manufacturers in Germany and throughout all Denmark, some companies that have used Rami or that were interested in it, but we couldn't find, it was too new, we could say. And what we figured out is that actually these models, they supported the explanation of the laboratory, of the production line we have here. And in our laboratory, we have this challenge that we have a lot of students coming in every 6 months that need to be taught about the laboratory, how it works. And so these models could be used for that. And then is that they also help structuring and collecting information, being these like guidelines on how to use some process modules or videos on how to start a robot or so forth. So these models could also be used for that. And so as I said, the contribution was that we understood which aspects could be modeled and which could not be modeled. Of course, this was the beginning of the research, so and we just did one iteration. But we had this starting point. And then we also figured out that actually these models can really be useful in disseminating information, in sharing information, because they are way more understandable than the data in the applications. So after having finished this project, we were really reflecting a little bit on the experience. And one thing we realized is that although we had interviews to create these models, we also realized that a lot of the information in the models was actually stored on the systems, on the information systems that we have in the learning factory. And this, combined with my previous experience as a consultant in working with these automated solutions like robotic process automation, and it was, okay, I really thought we must do something here. There is potential to start developing something, because it is not possible that we do this by hand. Also by interviewing. I also been doing enterprise architecture as a consultant before, and when you do these models, you ask one guy and then you ask someone else, and they tell you different stories, and then you need to find who has said which part that makes more sense. And so I was like, what if we have a fresh start somewhere else? What if we, instead of starting by interviewing and starting from scratch, what if we start by saying, okay, we have some data that we use actually to run our company. What if we start from there and then see, okay, maybe it's not perfect, but it's for sure a starting point. And this is what we wanted to investigate. We wanted to address both the challenge that companies, they refer to the same concept, to the same element in different ways. So we had, some of you are here that have this company that has customers, and in one system they are identified by the address, and only in the other system they have an ID, and they cannot figure out who is who on both systems. So we wanted to address this problem. And then we also wanted to start working on how can we do these models a little bit more efficiently. So we investigated how are enterprise architecture models created and enhanced with data and information from enterprise information systems. So we started looking at some literature about this automated modeling, and we discovered that there are researchers that had this idea before, but what we also figured out is that they use this to do like these very IT-oriented models for security purposes, So most of the solutions, they were using these network scanners that identify which devices are connected, for example, to the Wi-Fi, identifies which applications are used and the connections and protocols. So it's like all these very detailed IT models. And they were able to create these models by mapping essentially the data from the network scanner to the enterprise architecture platform that was then able to create the models based on the data gathered by the network scanner. But this solution, although it can fit for some of the models we have developed in the first year, it didn't really fit the more business aspect side of enterprise architecture models. And this was one important limitation. And then another fact is that these network scanners are actually not used for running the operations in the companies. So it's like, what if we use actually as a source the systems that are supporting the processes in these enterprises? And so we did. We started by developing this method, this AMA for EA, automated modeling with abstraction for enterprise architecture. That is a method to automatically abstract detailed data from enterprise information system to create these models. And we wanted to create this method that could be used for any type of enterprise architecture model, including EA models in the business aspect. And how it works is that data from enterprise information systems like ERP, MES, and so forth are extracted, imported in this tool, this tool here. And then what we figured out is that actually this data is not very useful if we just put it in the enterprise architecture models as it is. This is the big challenge. So we said, okay, what if we use some classification? We were doing something with production processes. And then we said, okay, what if we use a classification of production processes and use this classification to kind of standardize the data in the enterprise information system, though without changing the enterprise information system, but only changing the way it is represented in the enterprise architecture model. And so we did. All of this is done manually the first time, and then the tool has like a function that saves all the abstractions from previous processes and kind of suggests the previous abstractions to new processes. And then this is given to Qualiware, to the platform, and we developed some algorithms with the help of developers, both in Denmark and Sweden, where we then created these enterprise architecture models. Yes, so as I said, the beginning, this data is extracted, and here we use this Excel file, and this is done manually for the moment, but it could be easily automated. And then the interesting part that is also done manually at the beginning is this extension using, as we said, the classification of production processes. That also came with a specific notation. So when creating the models in the platform, then we also used this notation, which made the models way more rich and communicated way more information. Yeah, so this was our kind of first attempt with a method, and we're kind of happy that we managed to get this working, and finally using data from enterprise information system to create these enterprise architecture models. And then what we also figured out is actually it communicates the information that is in the system to people that have no experience about the system in a way that is way more understandable. So this was very important. So, coming to the last year, then once we had this first project done, we said, okay, now we want to collaborate with some companies. And we want to test this out with industrial data, how the same system, but the data from a manufacturing company. And so we did. So we contacted several companies. A few accepted to collaborate. We did the workshops and interviews. And we tried to address this process and data heterogeneity and this problem of very inefficient way of doing enterprise architecture models. And we did so in a company that explained and showed the fact that the same component was produced in two different sites. And in the ERP system, in one site, the production process was only 26 sub-processes. And in the other side, the production process was structured in a completely different way. It was way more detailed and had more than 200 sub-processes. And what is important is that they also show that they do a lot of business intelligence, or they gather a lot of data about the performance of their production process based on this level of detail. So in one case, they have very few measurements, you could say, only 26 for the 26 sub-processes, and in the other is way more detailed. And they even showed another company even showed some models, and they are like completely different. Like they are like, we cannot compare, even though we know they're doing the same part, but it is like so different, the process, the way it is structured, that we cannot use the data as it is now to compare. And so what we thought is like, okay, what if we start relating which activity in one site is the same in the other side, or is related to the one in the other side. And we did so by essentially creating this main process, which is this more high-level production process, and then going with another model in more detail about what are the activities in each sub-process. And this we did for the two sites, this lower model here. Yeah. So what we agreed with the manufacturing company is that, we're going to use the Danish process of 26 steps as our enterprise process. And then we're going to map on this the process in the other factory. And so we did. So by clicking on one activity, on one sub-process there, you can see which activities in this one side and in the other side are executed. So what the managers I was having this workshop with, they showed me that there was a kind of a relationship between these two the activities, but it was not just in the system. It was not there. And then one other thing they showed this thing about collecting performance measurements and so forth and documentation. We said, what if we also include this in the model? It will not be perfect, but it's like maybe a starting point to analyze what are common problems on both processes that you cannot see if you have 26 processes on one side and more than 200 on the other. Yeah. So with these models that we created using the method, we essentially started this comparison of performance measurements, of documentation, and of processes. And this is very useful because also, like, for example, product development specifies a production process, and then manufacturing takes it and makes something else. All the estimates they do, they're changed with real measurements, but it's not always the case that information is shared and updated and processes related. And then another thing is that with this extension we created, in our case automatically because we just use a process that was already existing, this overview and detailed view. So these are two different views of two different levels of the production process. So we could say that actually the data in the enterprise information system that in sometimes was acronyms and very not understandable words if you're not the one using the system, were actually made more understandable using these classifications and standards. So we had these challenges related to digital models and digital manufacturing, and we had these challenges related to enterprise architecture. And what we did is we tried really to explore how enterprise architecture models can be used, which can be used, is like really the starting point of these digital models that sometimes is called a digital twin of the organization. Some of you might relate to this terminology. And then we also said, okay, there is this big problem of creating the models manually. Let's start by developing this method to start to doing partly manually, but also automatically part of it. So it's been a very long journey, 3-year journey. And what I realized, that we've been talking with many companies. We've been really interacting with so many different problems and managers presenting all sorts of problems. And we often hear these data science projects that some of us are doing, digital twin of the organization, as I said. And I really think that the research presented here today, and I've also discussed this with several practitioners and researchers, is like a starting point. It could be used really to start better understanding when you're doing data science, how are your enterprise information systems structured, so that the acronyms in the systems are actually more meaningful because you have a model to relate, and then you can also visualize performance measurements or different types of measurements that you can calculate using, elaborate using data science, for example, in these models. So it also has the potential of being applied in different areas. And now a little bit looking at the future and a couple of reflections also about this is that it is very challenging. Although we all say it seems that the Industry 4.0 revolution is here, but for many companies it's still a long journey. And because especially established companies have legacy systems, have a lot of challenges to get all their IT infrastructure in place before actually undertaking this Industry 4.0. And also the way of thinking. I think we've really seen companies that the CEO wants to really go push product service systems and all sorts of things, but then there are no incentives to sell services, for example. The way the departments are measured, their performance doesn't reflect at all these transformations. So they still measure performance of the different departments based on the traditional way of doing business. So it's really maybe we also need to start incentivize this more cross-department collaboration. And I've seen actually in the last years that some companies have established these cross-departmental teams because they realize there is no other way for them to to do this, but it is still the beginning in oftentimes. So it is a long journey that they have ahead. So I hope that you learned something useful and that you enjoyed this presentation, and thank you all for being here.
So, thank you, Marco, for a nice presentation. As said, next session we will ask Marco some questions and discuss with him on his project. And you are allowed as well to ask questions. So if any of you have questions that you'd like to ask in the end of the discussion, please tell me during the break. Right now we'll have a 10-minute break. So in 10 minutes